So in this video we'll be going through shape vocabulary and properties. Now there will be a copy of the notes in the description below for you to download or copy, which I strongly recommend that you do while watching this video. So before we get started, a copy of the note sheet and what you can see on the screen is available for you to download in the description, and I strongly recommend that you either print this sheet off or you decide to copy this up in your own notes. Now, in terms of shape vocabulary and properties, this really isn't much of a physical maths topic for you to do. It's something that you kind of need to know and be aware of when dealing with shapes at an entry level in maths. So it's more of a case of like spellings and definitions that more commonly that you would use when revising certain areas in different subjects. So let's get started. So the first thing we'll look at is shape names. Now there are some quite common names of shapes that you need to be aware of, and this is usually defined by how many sides that it has got. So here what we've got is a name of some common polygons, which is probably something that we need to mention before we move on to this. Now polygon is basically a shape that uses straight sides only, so there are no curved sides on a particular polygon. And it's probably worth writing on this, so let's just get a pen. So a polygon is a shape with straight sides only. And there are some commonly named polygons that you need to be aware of, again based around how many sides that they are. So a three-sided polygon is known as a triangle, a four-sided polygon is known as a quadrilateral, a five-sided shape is known as a pentagon, a six-sided polygon is known as a hexagon, 7 is a heptagon, 8 is an octagon, 9 is a nonagon, 10 is a decagon, and 12 is a dodecagon. Now obviously you will probably realise that there are some numbers that are omitted from that list, like 11-sided shape or 13, 14, 15, etc. And it goes all the way to an infinite number of sides, which eventually would actually look like a circle. And again, it's up to you for you to research what those names are, but I would say the ones that you can see on the screen are probably the ones that you probably expected to know the names of. Now there are certain properties that come with these particular shapes, and like I said, a four-sided shape is a quadrilateral. Well, that kind of goes into more detail because there are several types of quadrilaterals which we'll move on to later on in the video. Now the first word that we look at is the word regular. So a regular shape is where all the sides and all interior angles are equal. So a regular triangle would be an equilateral triangle because all the sides are the same and all the interior angles are the same. So again, if we look at a regular octagon, a regular sort of quadrilateral, so this would be what we'd class as a square, and the reason for that is because all the sides are the same length, but also all the interior angles are the same as well. So although this is where it differs between a rectangle, whereas a rectangle can't be classed as a regular quadrilateral because obviously the sides are different. You have a pair of two different sides. So the word regular basically means where all the sides and all the interior angles are equal. And again, the interior angles are what we mean by the angles inside or at the corners or the inside corners of each of the shapes. So the next thing we move on to is again the word polygon. So a polygon is a shape with straight sides only, and so therefore a circle is not a polygon. A semicircle, although has got a straight side, is not going to be a polygon because it has got that curved edge. And there is an oval, and there are several shapes that you kind of need to know, but the general definition of a polygon is a shape that's got straight sides only. Now there are special names given to certain triangles and quadrilaterals that each have different properties, and you kind of need to be able to define and differentiate what each of those shapes are based on their properties. So let's have a look at some general notation. Now what you'll find is sometimes in maths that shapes aren't going to be drawn accurately, especially if you're drawing freehand, although your teachers will encourage you to use mathematical equipment such as rulers and protractors and set squares maybe to give your shape a bit more accuracy. So in terms of notation, you will find certain markings on certain shapes that kind of give you an idea about what properties that particular shape has got. Now usually equal sides are represented by a dash. So if a shape has got equal sides and lengths, then you'll find that it's got sort of two dashes on the line to represent that those two particular lines are equal. So for example, here on this triangle, we've got two equal sides there. So it means that this side here is the same length as this length here, which therefore would represent that this is an isosceles triangle. And because there's no dash on this base of this triangle, that would therefore mean that it's different length to the sides that I've marked in red. And again, what we do is usually mark that with a little dash on the lines to represent that they are the same. Now the next thing we move on to is parallel lines. Now the definition of two parallel lines are two lines that never meet but are also equal distance apart throughout. So what we mean by that is, as you can see on the diagram, is the length of the distance between these two lines is going to be the same. So if I measured that distance there and I measured this distance here, that these two numbers would in fact be the same. Now, one thing that you need to be aware of is when it comes to certain definitions. So if I just draw two lines here, these two lines are not going to be parallel for more than one reason. And one of the reasons is that if I measure the distance between at this point here, that distance there is going to be the difference between that distance there. But also, if I continued that top line and I continued the bottom line, you can see that the lines will eventually meet if I extend the line. So therefore, it shows that these two lines there are not parallel. And again, how we represent parallel lines can either be one of two ways. So usually we can represent it with a little arrow, or we can represent it as a double dash. Now, it all depends on if you've got more than one set of parallel lines. So for example, if I was to draw a parallelogram, and probably not that very accurate. So here, so this line here is parallel to this line here. However, I can see that I've also got another pair of parallel lines. So if I just highlight this here in blue, then what I would do is I wouldn't mark it with a single arrow, because then again, although it's quite obvious that this blue line is not parallel to the red line, although it's got one single arrow, so what I would do is I'd have it so it's got two arrows to make sure that the pairs of two dashed arrows lines, they're the ones that are parallel to each other. So it's kind of matching it up. So you could represent it with colour, or you could represent it with markings, and you go from there. Now also, it doesn't necessarily need to be arrows. You can have double dash lines, but basically if you see that on a shape, it usually means or implies that the sides are parallel. Now the next thing we move on to is perpendicular lines. So the definition of perpendicular lines are lines that meet at a 90-degree angle. So again, as you can see on the diagram here, that we've got this line here. So this red line is perpendicular to this green line because they meet at a right angle. And again, how we represent a right angle is with a little square. And the reason why we represent right angles with a little square, one, because it's a lot quicker than writing the word 90, but also the fact that a square, because an interior angle of a square is 90 degrees, it fits snug in that corner, and that's why it's usually represented by a square or sometimes a rectangle, depending on how closely and how accurate it's been drawn. So again, if lines are perpendicular, they're usually represented with a little box that's in between where those two lines meet. And again, another example here, you can see that these two lines are not going to be perpendicular because it's evident to see that these two lines do not meet at a 90-degree angle. So this angle here and this angle here are not 90 degrees. So therefore not perpendicular. Or not perpendicular, not perpendicular, should I write. And there we go. So the next thing we move on to are the types of triangles. So again, there are 4 types of triangles that you need to be aware of. And I'm just going to zoom out a little bit so you can see them all on the screen. So again, and it's important that you're able to spot these. Now, obviously, by looking at by sight, you can probably assume that triangles are one of these 4 types, but you've got to look out for the key bits of information that give you that sort of evidence to say what type of triangle it is. Sometimes triangles will be giving you lengths and angles in which you can make your assumption there, but other than that, you've got to look at the markings as I mentioned previously in this video. So the first type of angle that triangle that we're looking at is an equilateral triangle. Now an equilateral triangle is where all the sides are the same length and all the interior angles are going to be 60 degrees. So you could class this as a regular triangle. However, it's got a more common name as an equilateral triangle. And again, how we can define, how we mark an equilateral triangle is by identifying a dash on each line, which therefore represents that those 3 lengths or sides of that triangle are the same length. So therefore, it's an equilateral triangle. Now, the next thing, and by sort of default that these angles here on any equilateral triangle will always be 60 degrees because the interior angles, as I mentioned previously, have got to be the same. Now the next type of triangle that we move on to is what we call an isosceles triangle. Now again, the key properties of an isosceles triangle is that two sides are equal and also two angles are equal as well. And again, how we sort of represent a isosceles triangle, if we've not drawn it accurately or we've not got no markings or lengths of the two sides, is we represent the two sides that are equal with a single dash. And also that with any isosceles triangles, the two base angles will always be the same. Now those two angles that you can see here aren't set in stone. There could be any angles, but they've got to be the same. So if this angle here was 30 degrees, then this angle here would be 30. If this angle was, let's say, 75 degrees, then this angle here would be 75. So whatever angles the two base angles are going to be, they're going to be the same. And that's again one of the key properties of an isosceles triangle. The next type of triangle that we move on to is a right angle triangle. And again, the main properties of a right angle triangle is that the angle is 90 degrees. And again, this is identified by having a little box in the corner that represents that this is 90 degrees. Now it is possible for you to have a right angled isosceles triangle, and again if you've got that, then what you would find is that there'll be two dashes here on the two lines to represent that they would be the same length. And obviously if you have got an isosceles right angle triangle, then you'd find that this angle here and this angle here would be the same, and that angle there would be 45 degrees, and so would that one be. So it is possible for you to have a combination of different types of triangles, but again they tend to come more in specific questions. And the final type of right angle triangle you could get, I should say, is what we call a scalene triangle. Now in a scalene triangle, that is where all the sides are different and all the interior angles are therefore going to be different as well. So if there is no markings at all on the triangle, either on the lines or inside the triangle where the angles usually are, then therefore it's fair to assume that the triangle is a scalene triangle. And again, it's really important that you're able to know the difference between each of these four triangles, but also be able to spot it in a maths question. And we can just go in terms of there. Now the next thing we move on to is quadrilaterals. Now there are some special types of quadrilaterals that you're probably more aware of already, but it's also knowing be able to describe a quadrilateral as well. And it's usually quite a good game where you're guessing the quadrilateral using maths properties to describe them. Because again, all quadrilaterals are going to have four sides. So you can't just say, give me a four-sided shape and you automatically think it's going to be a square, because there are other four-sided shapes that you can draw. So moving on to the first one, so let's have a look at a square. So the key properties of a square, what makes a square special and unique, is that all sides are the same in a square, but also that all angles are 90 degrees. So if you were to describe a square, you would have to state those two key properties. Now how this differs to a rectangle is that, yes, again, we've got four sides, but here the key properties of a rectangle is that the opposite sides are the same length, but also we have two pairs of different lengths and all angles are 90 degrees. So the only main difference between a square and a rectangle is that you've got two pairs of different length sides. The next shape we move on to is a parallelogram. So again, the key properties of a parallelogram is that opposite sides are equal length, which shares a similarity with regards to a rectangle. However, the opposite angles are equals, and so they're not 90 degrees. So these two angles are going to be different. Now again, in terms of which angles are the same, so this angle here is going to be the same as the top corner or the opposite corner angle, and this angle here is going to be the same as this angle here. Now a key way to recognize what a parallelogram looks like, it's a bit like a wonky rectangle. So it's kind of like a rectangle that's kind of been nudged at the top, that's kind of just moved it like in the wind. Now the next shape that's very similar is what we call a rhombus. Now a rhombus has got where all the sides are equal, and again it's defined by very poor drawing, I should say, on the screen you can see, but again we can recognize this with a single dash. Now if I go back to the parallelogram, then I could identify a parallelogram as these two sides being the same and those two sides being the same length as well. Now in a rhombus, no sides are parallel, unlike with the parallelogram, so you want to look at the main difference between the two that look very similar. And so all the sides are the same lengths, but again, opposite angles are the same. So this angle here is going to be the same as that angle there, and this angle here is going to be the same as this angle here. So the main difference between a rhombus and a parallelogram is the fact that in a rhombus the sides are equal lengths, whereas in a parallelogram they're a bit different. So again, you want to kind of look at a rhombus as like a wonky square. Now, in terms of the other types of properties of a quadrilateral, so we've gone through the square, we've gone through a rectangle, we've gone through a parallelogram, we've gone through a rhombus, and again, what you want to kind of do is incorporate the types of angles you could find inside these shapes. And again, I strongly recommend that you practice and learn these properties of these different shapes, so when it comes up in an exam, you're able to identify and answer these questions. So again, when you're describing a shape, you want to comment on the lengths of the sides, the parallel and any perpendicular lines, and also the interior angles, and if how many similar or same angles that they've got in each of those, and also the types of angles as well, which again it will be included in another video if you're not sure. So again, another way of describing a parallelogram is two pairs of different lengths, opposite angles are the same, but if also you're in a parallelogram, you're always going to have two acute and two obtuse angles. In a rhombus, you've got four equal sides, two pairs of parallel sides, and two sets of the same angle. Again, you've got two acute, two obtuse. The next type of quadrilateral you can get is a trapezium. Now, the main property of a trapezium is that you've only got one set of parallel lines. And so here, now trapezium can either look like one of several forms. It could sometimes be resembled as a roof of a house, but it can also look like this shape here as well. So you can have what we call a right angle trapezium as well. But the main property of a trapezium is that yes, it's a four-sided shape, but it's only got one set of parallel lines. So for example, on this shape here, you can see that the parallel sides, and it doesn't have to be, the parallel sides have to be top and the bottom. It can be on the opposite sides if the shape has been rotated. Now you can also have what we call an isosceles trapezium, and this is where you've got one set of opposite sides are equal and two pairs are common angles. So what a isosceles trapezium would look like is where, if I draw, that's really poor, so let me try that again. And again, should be using a ruler, but it's a bit difficult on the screen. So with an isosceles trapezium, these two sides here are going to be the same, and these two based on the bottom are going to be based on the top are going to be my two parallel sides, and these are going to be equal lengths, and that's what we call an isosceles trapezium. Now the next type of quadrilateral we can have is what we call a kite, and it is, although it's the shape of a kite, the actual main name is a kite as well. And again, the main property of a kite is that the diagonals meet at a 90-degree angle. So in other words, are perpendicular. And what I mean by the diagonals are the dotted lines you can see. So for example, if I connect a line from this top point to the base and connect the opposite angles to each other, I can see that the diagonals, which are represented by the dotted lines, meet at a right angle or perpendicular in terms of the center. And that's unlike any of the other shapes, unlike a square where it's got that key property. Another property of a kite is that one set of opposite angles are the same. So for example, these two angles here are not the same, but, and again, let's get the pen, which I can't. However, this shape, this angle here, and this angle there are going to be the same. And that's always going to be the same. However, the angle that I've got here are going to be different. And again, so opposite angles in a kite, you've only got one set of opposite angles that are the same. And also another key property is that two sets of sides are the same. So here, not opposite sides are the same, but if I get a difficult pen, let's use green. So this side here is going to be the same as that side there. And this double dash line is going to be the same as the other double dash line. Now the other quadrilateral that tends to be quite popular is what we call an arrowhead, or an arrow, as it's sometimes sort of classed as. Now the main properties of an arrowhead is that it's got three acute angles and one reflex angle. And again, the types of angles, so acute is basically an angle that's less than 90 degrees, and a reflex angle is an angle that's more than 180 degrees. And this is the only type of quadrilateral that has got 3 acute angles and 1 reflex angle. Now, a question that usually gets asked to me is, how could these questions come up in an exam? So a question could either give you the description in which you need to give out the name, or a question might ask you is, what's the difference between an arrowhead or a kite, or ask you to describe the properties of a kite, in which you'd have to label those 3 things that are bullet pointed there. Now, the next thing we move on to is 3D shapes. Now, with 3D shapes, there are 3 main sort of properties that you need to be able to describe when it comes to a 3D shape. And those key properties are what we call the faces, the edges, and the vertices. Now, generally speaking, faces is basically the sides, in which that's relatively quite simple for you to look at. And what you want to try and do is not count the number of faces you can see on the diagram of the sheet or the paper that you've got in front of you. It's basically visualizing the actual 3D aspects of as a shape that you can actually hold and counting how many shapes. So what you want to kind of do is envision a transparent shape for you to be able to count certain properties that we're going to be looking at now. So faces is what we call the sides. Now edges is basically the sticks or the sides of the particular shape. So here we've got a cuboid, and here I've got 6 sides of this cuboid. And in terms of the edges, that's how many little lines that I have got to make that shape. So here I've got 4, 5, 6, 7, 8, 9, 10, 11, 12. Now imagine how I usually get students to remember the differences for edges is, imagine that you've banged your head on the edge of a table. So that could be any of the perimeter of that particular table, not just the corners. Now, an official name or mathematical word for corners is what we call vertices. So vertices are the actual corners of your 3D shape. So here you can see I'm representing with little balls and little circles, I should say. So here you can see that the number of vertices on a cuboid are going to be 8. Now the word prism is another word that we can use to describe a 3D shape. Now prism is a 3D shape made up by a pile of the same 2D shape. So in other words, it's got a consistent area. So for example here, now certain prisms have got more common names, have got unique names I should say. However, they can be classed as a prism based on the shape that is repeated to make that shape. So for example, on a cube, well, I could describe a cube as a pile of squares. So you could say that this is a square based prism because it is a square, and there you go. You can also have a cuboid, which is where you've got a rectangle that has been projected by length. You've also got a triangular prism, which is like a pile of this triangle at the front, and you can also have a circular prism, which is more commonly known, I should say, as a cylinder. And again, so a prism is basically a shape that has got a consistent area throughout. Now we call this repeated side of a prism its cross-sectional area. Now you can have different types of prisms. So here you can imagine that you see a loaf of bread. Now if you cut that loaf of bread into slices, you could say that that is also a prism because the area of the front is going to be the same for every cut that you make. Now, how we can kind of differentiate that is by looking at other 3D shapes. So here you can see that if I was to slice this shape here, that this circle here and this circle here are different lengths, so therefore that is not going to be a prism. If I look at a pyramid, if I was to cut this pyramid, let's say sort of horizontally, that this area here would be different to that area there. And imagine the best way to look at it is looking at this shape here. So if you imagine like a cone, that although you've got circles at the end of each particular shape, the fact that these 2 circles are different therefore make it not a prism. And again, so it's important that you know the definition of a prism, but also aware that there are some more commonly named prisms, but usually the name of a prism is given by the shape that it is repeated in its area.